Okay, concept 3 is all about rational exponents, which basically means you're going to have exponents with fractions. So our objective for this lesson is twofold. So I can, number 1, rewrite radical expressions using rational exponents. And then our second objective is I can simplify expressions containing rational exponents. Oh, I'm going to run out of room. Rational exponents. Okay, I just abbreviated rational. So those are our two objectives. So we can rewrite radical expressions using rational exponents because they are related. And then we can simplify expressions containing rational exponents. So you can change rational exponents into radicals. We can go from exponential form with exponents to radical form with radicals. It's really, really easy. So you may notice in this first example here, n is in the denominator of the exponent, and it's going to be the index of the radical. Okay, so the index is always in the denominator. So we'll do one more, and then we'll make a little note off to the side. So you may notice in this one, the nth root of a raised to the mth power. So we can rewrite this in two different ways. The n is still the index, okay, and we'll have a to the mth power. It can look like that, or it can look like this, with a as the radicand and the whole radical being raised to an exponent. That's totally fine. These are the same. I just wanted you to see that because sometimes you'll see it this way, sometimes you'll see it this way. So our little note off to the side is our index. So when we're going back and forth between rational exponents and radicals, the index is always in the denominator. Okay, so that's really, really important to remember. If you can remember that, changing from exponential form to radical form will be pretty simple. Okay. So for these ones, I'm going to change it up a little bit. I'm going to do all the evens. And then in class, we're going to do all the odds. I mean, I want you to try them before coming, obviously, but I'll do all the evens. And I'll try and go slower this time, even though this is going to be a little bit simpler than before, but I'll still go slow. So we're going to convert from exponential form to radical form, simplify if needed. So we have in parentheses, if there's ever parentheses, what's inside is your radicand. It goes underneath your radical. Okay. And then what's in the denominator? A 2. So that means your index is 2. But remember, if it's 2, I don't need to write it. So that is our final answer for number 2, square root of 15n. Okay. In number 4, the 7 is our radicand. Okay. Our index is what's in the denominator, so it's 3. And it's 7 to the 2nd power. So we are actually going to simplify this. 7 squared is 49. But I cannot simplify that anymore because I cannot take a cubed root out of 49. So that's our final answer. Okay, see if we can do this one. 3 is our radicand. 4 is our index. It's 3 to the 5th power. So before we evaluate with 3 to the 5th power, let me show you a really cool way to do this. A really, really easy way. If I have 3 to the 5th power, and I'm trying to find the 4th root, I can take out 3 to the 4th power. Okay, so the same thing we did with variables and exponents before, we're going to do with 3 and exponents now. I can take out 4 3s because I have 5 of them. So 1 3 is going to come out because 4 goes into 5 one time with 1 3 left over. Okay, so hopefully that made sense. I had 5 3s. I wanted to take out groups of 4, so I could take out 1 group of 4 with 1 left over. So that's why that becomes that. Okay, this one is our radicand. What's our index? If you said 3, you're correct. And we're raising this to the 2nd power. Okay, I'm going to simplify this a little bit. It's still an index of 3. Negative 6 squared is 36. X squared. And that's our final answer.